All right, let's look at an example that's somewhat similar to problems that you have in the homework. So in this case, what I want to do is I want to plot a piecewise function. All right, so a function that is defined over certain ranges and not over others. So in this case, I've said this function is called x of t, and I want to plot it over a time vector that goes from -4 in steps of 0.01 up to 4. So if I look at the picture that I've been given here, it looks like I can define my x of t as this piecewise function like this, so with the squirrely bracket. I can say mt plus b, that's the equation of a line, right? Remember, y equals mx plus b is our typical equation of a line when I have a y-axis and an x-axis. M is what we called the slope, and b is what we called our y-intercept, right? In this case, my y is x of t, and my x-axis is t, right? So in this case, I would say x of t is equal to mt plus b. That's how I would define with these variables what a linear function looks like, okay? And I'm going to say that based on what I can see here, this is true if t is between 0 and 2, okay? Otherwise, if t is anywhere else, x of t is equal to 0, okay? That's the perfect kind of thing for us to define and to do using if statements in Matlab. And so we need a little bit to learn about how to do that. So before we move on, though, I don't know what the slope m and the y-intercept b are, so let's try to figure those out. So m is always our slope, right? So that's rise over run. So the rise here, I rise from 4 to 10. So I do 10 minus 4 divided by our run, which is from 0 to 2. So 2 minus 0 is 6 divided by 2, or 3. So my slope is 3, okay? My y-intercept here is where I hit the y-axis. So this line hits the y-axis at 4. So b equals 4. And I can say that x of t is equal to 3t plus 4 over this range from 0 to 2. Now, in your case, you may have multiple ranges, in which case you may have to write out the equation over each of those ranges, right? And it's going to be different over each range, potentially, all right? And so you'll have to think about how to do that. Now, this is a perfect example of where I can use an if statement in Matlab. So let's look at how to do that. So I'm going to move this over to the side, and then over here is the code that I wrote. All right, so let's begin with the basics, right? So first thing I do is I define my t vector, which goes from -4 in steps of 0.01 to 4, all right? Straightforward, you've seen it before. All right, then what I do is I defined x, all right? That's going to be my output vector. That's the thing I'm going to plot, right? This is basically my x of t. And I'm going to say x is equal to squirrely brackets, or square brackets, sorry, x equals square brackets. All that does is it creates a vector with no entries. You don't even really necessarily need to do that, but I'd like to initialize the variable that I'm going to use and say that essentially that it's got nothing in it, okay? Then I have this for loop. Now what the for loop does in this case is it's got this dummy variable n, and it uses this dummy variable n to loop through every entry in the time vector. And what I'm going to do is, as I go to each entry in the time vector, I'm going to compute the corresponding value of x at that point in the time vector. All right, so that means that what I got to do is, as I loop through this time vector, I need to check, well, what is the time? Is the time between 0 and 2, or is it otherwise? Okay, if it's between 0 and 2, then I want to plot this linear function. Right? If it's something else, then I want to plot a 0. Okay? So that's what my for loop is doing. It's basically looping through every entry in the t vector, and at every entry in the t vector computing an output x. All right? So I say that I'm indexing or looping through the t vector. So n is really what I use as my quote-unquote index, which tells me where I am in the t vector. So I start from n equal to 1, meaning I'm going to start at the first entry of the t vector. I'm going to increment in steps of 1, and I'm going to go to the length of the t vector. If you're not sure how the length command works, type help length. All right, we talked about it in class on the second day, but you also should be able to see how to do that by typing help length. Now, what I then have in here is an if statement, right? And I have the if statement because in my original expression over here, I have two ranges. One range for t between 0 and 2, and one range for otherwise. So I have an if statement that is intended to look for values between 0 and 2, and then I have an else statement that looks for the otherwise. Now, let's look at how we can understand that expression. So I'm going to try to pull over here on the Canvas page. I created this module called Matlab links. So what I have here, this Matlab if, else, if, else. So I'll click that link, and then I'll go here. All right. What this brings me to is the MathWorks page that describes if, else, okay? So I see the syntax here. It says if expression, then statements. So if this expression is true, it'll evaluate these statements. Else if this expression is true, it'll do these statements. Else if, basically, if neither of these two things were true, then it'll do whatever is these statements say, okay? And it gives us a description of that, basically. It says, if expression statements end, evaluates an expression, and executes a group of statements when the expression is true, okay? When the expression is true. So if this expression is true, then these statements are evaluated. All right, now notice it also says some other stuff here. It says, else if and else blocks are optional, okay? And it also says you can have multiple else if blocks. So you may need that potentially in your assignments, right? Is you may need multiple else ifs. All right, so in this case, I don't need any else ifs because I really only have two ranges that I care about. One when t is between 0 and 2, and one for everything else. So the else here basically catches everything that's not between 0 and 2. Now notice if I go back to the description here, I don't need any statements after else. It just goes to else if everything else above it was not true. Okay? So in this case, let's take a look at what I did. Basically, for my if statement, I say if t of n, meaning the entry at the nth index of the time vector, okay? If the entry at the nth index of the time vector is greater than or equal to 0, that's what this means. And if the entry at the nth index is less than or equal to 2, in other words, if at point n in the t vector, if the t value is greater than or equal to 0 and less than or equal to 2, then evaluate this expression. Okay? So in this case, let's see, on the Canvas page, I also have, go back to the main Canvas page. Back to the main Canvas page, I have this Matlab logical and relational operators. All right, this is taken from page 141 in the textbook. So if you have the textbook, you can take a look at this. But this basically lists the key Matlab, what we call logical and relational operators. So relational operator, what it does is it checks the relationship between two numbers. So here's greater than. Here's greater than or equal to. Here's equal to. So notice equal to is two equals. All right. Less than or equal to. Now this one's harder to see. This is not equal to. This is so you see the equal sign here, but in front of the equal sign it's a tilde. All right, the tilde is usually next to the 1 on your keyboard. Okay. These guys are what we call relational. All right, they check the relationship between two numbers. Okay. And so if you look at this example here, like they said A equals 10, B equals 2, right? So if you look at this, A is greater than B. This is a true statement, okay? A is greater than or equal to B. That's also a true statement, okay? Now, there are also what we call logical operators. All right, logical operators are basically are sort of logic statements, right? The vertical line here is an or statement. The ampersand is an and statement. Okay, so those are really key. The ampersand is an and. That vertical line is an or. Okay, that vertical line is an or. So you can check that this value should be true if you go back and you look at what it's comparing here. So it says AGTB, AGEB, right? So if I looked at these things here, AGEB was a true statement. That means if you were to execute that statement, that command in Matlab, true would mean that you would get a 1, okay? And so in this case, AGTB, that was this statement here. So I have a 1 or 1, that's obviously going to be equal to 1, okay? And if you look at the example here on this next line, right, I have AGTB and AEQB. If you look at that, let's see, AGTB is a 1, it was true. AEQB was false, it was a 0, right? So I have 1 and 0. That's obviously going to be 0 or false, okay? So in this case, I use those relational and the logical operator, right? I said if t is greater than or equal to n, or sorry, if t of n is greater than or equal to 0, and if t of n is less than or equal to 2, so in other words, it has to be in that range between 0 and 2, then I'll execute this statement. All right, and the statement that I'm specifically executing is exactly the one that I wanted it to execute here, right? I want it to execute in that range, this 3t plus 4 statement. And explicitly I'm saying that x at the nth index is equal to 3 times t at the nth index plus 4, right? I'm basically just computing the value at one point in x using the value of time at the same point. All right, so then at the end I just make a plot here. So let's run it. And there's my graph. Looks exactly like what I would expect it to do, right? You may have more sections that you have to define. Let's say you have basically 2 piecewise linear sections, one between 0 and 2 and one between 3 and 4. Well, in that case, I would need an if, an else if, and an else. Okay? You'll figure it out.